Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Abdul bin Ismail. So today I will present about mini project MEC684 bottle packaging. Introduction. So this project is for Eagle SWAT Sdn Bhd. Plastic bottle is described as a plastic container with a body that is large in diameter than the opening. Variety of design, shape and size for plastic bottles. Food, beverage, health, beauty, domestic, garden, automotive, industrial, vitamin, and pharmaceutical. Packaging may provide businesses an advantage in a competitive market. Inventive design can also assist customers in mentally associating a product with a brand. So, problem statement, how to create a system capable of packaging the bottle on its own, how to create a solution to shorten the bottle packaging process, and lastly, how to create a low-cost bottle packaging system. Our objective are to develop a bottle packaging technology that can function without human intervention, to shorten the bottle packaging procedure on the production line, and lastly, to create a cost-effective bottle packaging technology that performs well. Concept design. We have three concept design. First one is proximity sensor, detect the amount of bottle before operating. Gear motor to move the bottle grappler and move it to packaging conveyor. Weight sensor, detect the mass of loaded boxes before moving the conveyor. Can detect the amount of object. Can hold heavy weight. Can detect the presence of mass. Second concept, servo motor to rotate the box after unfolding. Pressure sensor detect the mass of bottle adequate before the machine can start to work. Rotate and move the box to detect the presence of mass. And the last concept, vacuum suction to lift the bottle before dropping into the box. Motor to move the vacuum suction forward. Able to hold load momentarily, can withstand heavy weight. So this is our flowchart for the system. Start, bottle detect by sensor. If the amount of bottle more than 12, yes, send output to the component. If no, bottle detect by sensor. Send output to the component. Actuator move first blocker to blocks remain bottles. Actuator move second blocker to adjust bottle to the position. Gear motor move sucking pump to pick the bottle. And actuator transfer the sucking pump to the box and the box is filled. And then the process is end.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Abqari. Next is product description and details. Our bottle packaging technology necessitates the use of various components. The input was detected by a component and the output was produced by 4 sets of components. Here is the product design of our product. Here is the first stopper and the first stopper's actuator, where it will block the remaining bottles. Here the second stopper and second stopper actuator, where it will move the bottles to its position before being picked by the pump, sucking pump and motor and gears, where it will lift the bottles before going to the side of the box, and the actuator, where it will move the sucking pump gears to the side of the conveyor belt of the box. Here is the box holder. The box holder will keep the box from moving from its position. And here is conveyor belt for bottles, conveyor belt for box, proximity sensor will be located near the first stopper. It will detect the amount of butter going through the sensor. Which sensor will be located under the conveyor belt for box. It will detect the weight of the box before it will move the conveyor belt to the next empty box. Here is the design of our products. Next is result and discussion. Our team create a bottle packaging tool to help with the packaging of mineral water in the manufacturing line. This bottle packaging tool is activated when the water-filled bottles have been through the sensor. Proximity sensor was utilized as an input to determine the specific quantity of bottles. 12 bottles of water are required in order for the packaging machinery to begin operation. Once the 12 bottles of water have passed through the sensor, it will send the output to the actuator that will block the remaining bottles. Then another set of actuator will move the bottles into the position before the bottles were being lifted. The motor will then move the suction pump downward and grip the bottles. Gears were used to move the suction pump vertically. The bottles will be transferred using actuator toward the side of the conveyor belt with the box. The motor will move the bottles downward toward the box and load it into the box. Weight sensor will detect the loads of the box when reach the required weight of the full box with the bottles, the conveyor belt will move for the next empty box. All of the components will automatically return to their original position after completing each round of the operation and will stop operated when there is not enough amount of bottles detected by the sensor. Here is the diagram of our components for our product. So as a conclusion, this assignment's aim is to increase the performance of the bottle packaging production line. The difficulty remains, however, how to go about doing so. As a result, we begin with a process study to ensure that we consider every aspect of the production line. It was discovered that the production line necessitates manual labor throughout the final packing phase. We create a conceptual approach to handle this challenge and thereby increase line performance. The conceptual model was then turned into simulation model in order to evaluate potential adjustment on the manufacturing line. This approach makes use of a proximity sensor, weight sensor, motor, gears, and actuators. After the water-filled bottles are transported to the packing area through the sensors, the procedure begins. It comes to a conclusion when the bottles are placed into the box as a final packing. The performance of the manufacturing line will improve as a result of the implementation of this technique. This is because the manufacturing lines throughout is boosted, allowing for more items to be produced at the same time. That's all from us. Thank you.